Hello students, welcome to grade 10 mathematics unit 2, which is exponential and logarithmic functions. We'll try to see basically here about logarithmic functions and graphs of logarithmic functions. We'll try to determine basic properties of a logarithmic function and what the relation between a logarithmic and exponential function. Look, what are the techniques, properties to draw graphs of logarithmic functions, and also what are basic properties of a logarithmic function graphs. Here, a logarithmic function is inverse of exponential function. A logarithmic function is taught as inverse of exponential function. When we say it's inverse of exponential function, we know that a definition of exponential function is f of x equals to a to the power of x for a greater than 0, a different from 1, and for any number x. So inverse of this function is obtained by interchanging a place of x and y. So this one is f of x is simply y, that's a to the power of x. So if we interchange x and y, this equation will be changed to x equals to a to the power of y. So if we find logarithmic statement of this exponential form, or if we compose both sides by logarithm to base a, it will be reduced to f of x equals to log x to base a for x greater than 0, a greater than 0 and different from 1. So any function that can be defined in this form is what we call a logarithmic function. The function defined by f of x log x to base a for a positive number x for a greater than 0, and it must be different from 1. So we'll try to look at graphs of logarithmic function by considering two different cases. One, when f of x equals to log x to base a for a greater than 1. When the base is greater than 1, what looks a graph of a logarithmic functions. And also, when the base a is between 0 and 1, what looks like a graphs of a logarithmic functions. These are some of a logarithmic functions. The function f of x equals to log x to base 2, g of x log x to base 3, and h of x log x to base 1 over 2 are some of examples of a logarithmic functions. So we'll try to look what are properties and what looks like a graphs of such logarithmic functions. Now let's try to draw a graph of log x to base 2 using table of values, and later we'll try to determine its property. Let's draw using table of values for some integer value x. Here we have x here, log x to base 2. Then we can take any positive value of x, but we can choose systematically the values of x that can simply computed with base 2, or values which can be written to the power of some constant, either a fraction or a whole number. So at x equals to 4, what's logarithm of x to base 2? That's logarithm of 4 to base 2 is 2, because to the power of 2 is 4, and at x equals to 2, logarithm of x to base 2 is 1, and logarithm of 1 to base 2 is 0, and also a logarithm of 1 over 2 to base 2 equals to, we can apply property of logarithm, it's log to the power of minus 1 to base 2, so it is minus 1 times log 2 to base 2, but we know that a logarithm of any number, any positive number a to base a is 1. So the value of this is equal to minus 1. So using this table of values, let's try to locate these points on the coordinate axis. And here, if we observe, the values of x are only positive numbers, because a logarithmic function is defined for a positive real number. Now, at x equals to 4, what is the value of y? Is 2. And at x equals to 2, what is the value of y? It's 1. at x equals to 1, what is the value of y? It's 0. Then if we connect these points by a smooth curve, a graph of f of x equals to log x to base 2 looks like this. So by looking this graph, we can determine basic properties of a logarithmic function. What are basic properties? Like domain, range, increasing or decreasing, x-intercept, y-intercept if it exists, and also an asymptote. Maybe a vertical asymptote or horizontal asymptote. And also functional values. What are the functional values for a positive number x when it is greater than 1 and when it's